Supplemental math videos from Circle Christian School.
The heart of algebra. This is your study guide. An easy review is, remember to use your notes. Take a look at those notes. This is the reason why I had a blank on the back page here. Condense key points into 1 or 2 pages at most from your spiral. Do a couple practice problems. Look at the study guide just before the review exercises to fill in the little gaps. Avoid cramming. Prime your brain. Get yourself a little study group and give each other a test. The problems on this test are just, that's it. It's going to be math problems. So all you're doing is actually practicing the algebra. It's not going to be SAT, I'm going to trick you type of stuff. Okay, get yourselves ready. Here's your study guide. Start with your notes. Take a look at the Chapter 1 review. Looking at your notes from every lesson, try a practice problem. Use the back page, the blank pages, to just make discoveries from what you look at. Cute little discoveries. Don't say, hey, I know how to do it. Put down exactly what it is that you know how to do. Now start your study guide video notes. Prime your brain at least twice by looking over your notes for 15 minutes each time. Simple as that. Start with page 3.1 and work yourself through 3.6. Just look at the lesson forwards just for a second and look at a problem, basic problem of how to do it, not so much the SAT way, but the basic way of doing the problem. And if you feel good about it and you go, okay, I know how to do that, you just move on. But it starts out with getting x by itself. First, we're going to do that simplifying thing. You're going to simplify, and simplifying means you're going to distribute and combine any like terms. So you've got anything that needs to be multiplied, and then combine your like terms, anything that needs to be added or subtracted. Watch your integers. Big number carries a sign. Work on signs first, math second. Isolate the variable. Put a circle around that variable thing, and you're going to use the additive inverse. That means you're going to subtract, add, whatever the opposite is from equal sides of the fence there. I like doing mine vertically. Things I like to include is that little fence of equality there, and working left to right consistently all the time. Don't do some on one side and then some on the other side. It just gets crazy doodle at that point. And then you're going to isolate that variable by using a multiplicative inverse. All right. Now, most students do pretty good with the fact that say, hey, you have 3x equals 15 here, and that you're going to divide out a 3 and divide out a 3. The ones that get kind of crazy is when you have something like 1/2 x equals 12. Well, it's a division problem, and because it's a division problem, what you need to do is the opposite, which is multiplication. You need to multiply by the reciprocal. So don't get freaked out. Remember that the multiplicative inverse is also known as the reciprocal property. Circle your answer. Make sure you answer the question. Okay. We always start with the fence of equality anytime we do this, but you'll notice I don't have an equal sign. What I'm going to do is actually simplify this particular problem, and that means we need to distribute and then combine any like terms. When we distribute, remember that you're multiplying number to number and letter to letter. Okay, so we have 4 times the positive 2, and if you talk it out a little bit while you're doing it, even if you just mouth the words, it actually slows you up a little bit to see all the different parts, and it helps you with the integers. And so my mouth is kind of going to say 4 plus, or 4 times a positive 3, which means signs first is going to be positive, and a 12x. And then 4 times the negative 1. See, that's how I kind of help myself with the integers here, is by saying it and following each one bit by bit. Bless you, buddy. Got my little buddy here helping me with my computer. We got a -4. Okay, now this is going to be a positive x being multiplied to everybody. Circle the sign that's in front of it. Again, it keeps the integers happy. But oh no, we have to actually look a little bit at an order of operations here. And the order of operations says, well, wait a sec, Mrs. Washington. We have to do exponents before we do any multiplying or distributing. So we have 2x plus 1 times 2x plus 1. We have to power up the parentheses. And so that's going to lead us to x times the polynomial here, the little quadratic equation. This is one of those 5-second ones. The first one squared, the last one squared, and then 2 times the middle here. All right. Now it doesn't hurt, and I know it does take time away from a testing type of situation, but if what you are doing is practice or doing a test, then it's okay to just rewrite your steps. Do a process. Again, that helps with those silly mistakes. And so I'm going to distribute the x to everybody here, which means I'm going to go letter to letter. All right, now we have nothing but addition and subtraction. So we're going to add and subtract left to right. You always go through, put things in nice order, put things of the highest power, and work your way down in the powers here. All right, I like to put little things underneath them just so that I know I've used them and put them together. And so the 4x to the third power is the biggest one there. And then I'll put another symbol. I'm going to go find anything that has power 2's. Notice I'm putting a kind of different shape here. Plus 12x2. I have a kitty on my lap, but he looks like a little grandson. Okay, so I'm going to go through and find my x's. So I have a 12x plus an x. Remember, there's a 1 in front of there. So plus 13x. And then we have the last one left over there, a -4. And see, I know I haven't missed anything because everybody has some sort of little symbol or congruent little symbol under it. And that way I don't lose parts and pieces. All right, let's solve. And we're going to use the inverses here. And in solving and using the inverses, I always like to start with the fence of equality here. And we make sure we don't have to do any simplifying first, and we don't. And we want to get rid of all addition and subtraction. Remember, I like working from left to right, so I'm going to deal, and I like my variables over on this side, my constant numbers to end up on that side. Doesn't always happen. But if you consistently do these by left to right, then it seems to work pretty well. Okay, so we add the 15. I'm going to add the 15, and I always put the sign with it. You know, don't deny the positive plus sign here. Again, it helps you out with the integers. Alrighty, here we go. And now we want to get the constant number by itself here. So I'm going to minus the 6, and if you want, you can put a little positive there. See, it just, again, helps you out with the little integers. It's a nice little study tip to do here. Big number carries the sign, so math first says it's going to be a negative. Got my little helper again here on my computer, drinking his sippy applesauce. And I think he's going to get down here in a second. Either that or he's going to play with the puzzle. And you can either go ahead and put this into a mixed number. That means it has a whole number and a fraction. Or you can just reduce the fraction. That's perfectly fine. Both of them will grid in quite. No, the mixed number won't grid in very well, so you'll have to reduce. Let's see, and we're going to get what? 15 over 2. Okay. And we'll do the next. Okay. So same thing. I like having a little fence here, especially if what you're doing is working on a little bit of organization and curing those silly mistakes. Now in this particular problem, you'll notice that we have a couple fractions. And if you have one fraction, make everybody a fraction. And one way to simplify this, especially ye who hate fractions, is we're going to ditch the demon. We're going to ditch that denominator. And, all right, going to ditch the demon here. And the demon is just going to be your least common multiple, 4, 1, 5, so we know we have 20. And what I'm going to do is multiply 20 to each one of these, because that's going to allow me to cross out that denominator. Bless you. I think we're going to have another fuzzy wuzzy pickle. Nope, maybe not. I thought we might. Okay, so I'm going to, we get a 5. So I like doing these each one by one. Minus sign. 2 times the 20 is going to give me a 40. And somebody lost his Mickey Mouse, so we're going to have to get Mickey Mouse back again. Just the wonderful things you get. 8x plus 120. Now, voila! We have a linear equation, no fractions, makes it nice and sweet. And we can go and solve. Now the deal here is that you really want to beat me in solving this and finding out what x is. So anticipate my steps here. Don't just watch. Run it ahead, pause it, do the problem, see if we get the same thing. And let me get to here. My little buddy wants to check out his airplane. 160. Let's see. So I know my answer is going to be negative. And I can do a little bit of short division. That 3 into the 16 goes close to a 15, so a 5. And that would give me 1 left over. So that would give me a 3. And of course we would go on forever and ever and ever. And that's one way, one way to do the answer. Right. Polynomial expressions and equations. Now the only difference between the expressions and the equations is with expressions you have to simplify. And with an equation, of course, what you're going to do is you're going to solve. And when you solve, every linear problem basically gets its answer by using the zero product rule. That is, basically you always equal it to 0. That's why you have general forms end up equaling 0. When we multiply, remember when multiplying, we go number to number, letter to letter, binomial to binomial, and radical to radical, multiplying or dividing. And dividing is when you have fractions, maybe you've got some polynomial up top and polynomial down below. When you add and combine, you're going to add or subtract, and you're going to do this by doing it with the coefficients. The coefficients, the number in front, tells you how many. And when you add and subtract, remember that you are combining things that have a same letter and a same power. Here you go. Okay, we're going to solve some quadratic equations. Remember, what you have to do is factor to solve. That means that you're going to factor first and then set everything, let it equal 0. There we go. Push one. All right. Now these are the quick ones because it has a leading coefficient of 1. So we have x and we have x. And then we got to find factors for a negative 10 that when we add them together equal that 3. And we know some of the factors are 5 and 2. And because this is positive, that means that the big number is going to carry the sign. We let it equal 0. This is going to give us two factors. You have to have a single x. And of course, if you got something to the power of 2, that means there's going to be two answers. So the quick and the easy here is, of course, it's just going to be opposite sign. So we have a negative 5 and a positive 2. And then throw it back in or do what they ask, maybe you need the product or you might need the sum, especially if it's a grid in. Now the quicker one, this is what I call the 5-second one, is when you have the binomial squared. And I see if I have a perfect square up front and a perfect square on the back. And if those two numbers for the square on the back added together give you the middle, then you know you've got the binomial squared. And that means x is going to equal 5. And that 5, because it has two 5s, is what we call a multiplicity in pre-calculus. And that multiplicity means it has one multiple number, so it would have a multiplicity of 1. So you got a little bit of pre-cal in there. Multiplicity. So when they ask for a multiplicity, they're not asking for what the number is that got repeated. It's how many times a number did get repeat. So it has one multiplicity. And then, of course, the quickest one is going to be my favorite. And they love these. You'll see this in a lot of places where you have to factor the top and you have to factor the bottom. And you're going to do crossing out. That's the binomial to binomial. And that's your difference of two squares. Difference of two squares. Square minus square. 7 and a 7. And so you have a plus and you have a minus. And again, when you're solving, it gets set to 0. And you're going to take each one of these factors. Each binomial is a factor, and you're going to set it to 0. So x here would equal a negative 7 and a positive 7. Okay, let's see how much the music. Remember to always factor completely anytime that your leading coefficient doesn't equal 1. And here we see we've got a negative, so we're going to factor out the negative 1 here, which just means we're going to change all the signs. And the big reason you got to do this is because your x will equal the right sign when you get to the end. And so we have negative 1 times our double bubble here. And I'm going to give my little buddy high five here because he put it in the box, put his toys away in the box. We got 5 and 2. Big number carries a sign. So obviously, and all three of these are factors here. We got to set all three factors to 0. And obviously a -1 isn't going to equal a 0. But we are going to have that x equals opposite sign, a -2. And I like kind of just putting them in order here. That's all. And that's why I did the 2 first and then the 5. On the next one, you see we start with a power of 3. That means we're going to have 3 answers. So there's going to have to be something that gets factored out of here. And in this case, we're going to factor out an x. Sometimes this is really hard to do when you've got a little 2-year-old running around and he's doing just incredibly funny things, like trying to swing on your purse. As a matter of fact, now he's going to try to go through my purse. I don't know if that's such a good idea. But we have an x and an x and a 1 and 1. And we see we're going to have one of those little multiplicity things, a repeating answer. And so we got to set the x to 0 because we have 3 factors here. And x is going to equal a -1 and -1. We have a multiplicity of 1. Just so you can hear a couple little pre-cal words. And since on my next one here, I see that I've got a 2 in front here. And so I check to see if I can't factor out at least a 2 from everybody, and of course I can. And then what we can do is, factor by grouping after that. But since my x squared here has a leading coefficient of 1, it's that nice, easy little double bubble. 16. 2 factors for 16, 2 and 8. That in some way, if I add them together, is going to give me a 6. Big number carries the sign. Things to remember. And again, obviously the 2 is not going to equal the 0. It's a factor. And x is going to equal opposite sign and opposite sign. Let me go rescue my purse. Okay, ditching the demon. And this is, again, when you have a rational expression. Rational expression means you've got little variables hanging around in the denominator, which make just really crazy problems. But again, we're going to ditch the demon like we did earlier, get rid of that denominator, and we need to look for the least common denominator. And when you've got letters down in the denominator, it's just one of each. So we have a binomial square here, which means I have x minus 1 and x minus 1. So we have one of those. And because that one already has it, it's included. And then, of course, we have a 1. But because 1 is 1, we don't actually have to include it here. So I'm going to multiply everybody by that common denominator because I want to ditch my nice little demon. And x minus 1 and x minus 1. Oops, kind of got up into there, but it's okay. All right, so that's going to get ditched, see? And so all those are gone. Leaves you with the 10. And one of these and one of these leaves you with the 2x minus the 1 equals the 6 times the binomial here. And the binomial gives us x squared minus 2x plus 1. So it's going to be 6 times that. So now we're going to combine our like terms and move everybody over to the other side so it can equal 0. We got a power of 2. Somewhere in the problem, it means we need 2 answers and we have to set it to 0. Now the question says m and p are the roots. What is the product of the roots of m times p? Now this is a good case for that sum and product property that happens with quadratic equations. The sum of the first root plus the sum of the second root always equals negative b over a. Just a good thing to remember with these, because this may be one of the problems, and instead of factoring the equation out here, which we would have to factor completely, we know we can take a 2 out, and that's still going to leave us with a coefficient here, so we're going to do the factor by grouping, but I'm going to bypass all of that for the sake of time here. And remember that the first root times the second root always equals c over a. Much easier way to do it. So c is the negative 2, and the a is the 6. So my answer for the question would be a negative 1/3. Just really great reasons to know that property of a sum and a product. All right, something that you can do is use the Unlocking Algebra book, Algebra 1 book, and looking at Chapter 3, there is a practice, page 92. It's a great practice test. It's only 10 problems, and it's worth 100 stars. Put it in your notebook there that you're going to turn in Thursday, your odd notebook, and I'll be checking everything that we did week 3 and week 5, and this as your practice. All right, guys, I think you're ready for the test. Like I said, it's just going to be practical problems, simplifying, solving x, multiplying, binomials, some easy simplifying of rational expressions there, and finding x when you set everything to 0. You'll do fine.